Hi there, this is Willy Wang. I'd like to share with you my understanding of Zero Trust Architecture, ZTA, and how it compares with cloud access security broker CASB. We're going to talk about the origin of the term, its key components logically and functionally, and how it is related to some of the trending technologies, and finally, an overview of how it is different from CASB. The term zero trust was first coined by Stephen Paul Marsh in his doctoral thesis in 1994, formalizing trust as a computational concept. The term later became popular since 2009-2010 thanks to Kinderwag from Forrester, who started to advocate the notion of never trust, always verify, especially in the context of network security. A typical corporate network used to be segregated from outside in the order of public network, DMZ, and private or internal network. The internal network, that is the inner circle, was regarded as a trust area. Once access granted, there will be little to nearly no further verification. The zero trust idea by John Kinnervag challenged the network security at perimeter. As information security threats getting more and more sophisticated, like insider threats, protection at perimeter is not enough. You must always verify, even inside the internal network. Correspondingly, the zero trust model, zero trust architecture are developed to respond to the challenge. But we might want to ask ourselves, is ZTA really something new, or is it just a repackaged old concept? I think the term zero trust that was created by Marsh in his dissertation in 1994 was a new idea in that it turned trust from an abstract subjective perception into a computational object, something that can be revised and whose value can be measured. On the other hand, the zero trust promoted by Kinderwag in network security discussion is a more like an ominous but truthful description of the problem facing us. It's like a wake-up call, but a call for a new mindset and therefore a new direction of what information security should be heading. Having said that, what does ZTA look like? Let's look at the logical components in ZTA. This diagram has been widely quoted in many research material and marketing collaterals when ZTA is introduced. The subject or the client here, which can be a user or device or an application that wants to access a resource sitting in the controlled area. The resource could be a file, a record in the database, or a service, etc. In between is the control that allows legitimate requests pass and blocks the other attempts. The control is supported by policy administrator that defines who can be trusted and who cannot be, and the engine is the brain that makes the decision for each request. Those elements listed surrounding here are the factors that should be considered or the tools that can be used to facilitate the control plane, the control panel. If someone just shows you this diagram and tell you this is what ZTA is about, you might not be 100% satisfied because the notion of a data plane, control plane is commonly used in too many access control implementations, and the technology listed here are also in use by tons of other security solutions. So what's special about ZTA? Let's take a look from its capabilities perspective. Here are the four cornerstones that support ZTA: identity authentication, access control, trust evaluation. These are familiar terms. CDM, continuous diagnosis and mitigation, is less commonly known, but it's still easily understandable. You can take it as continuous monitoring and dynamically fine-tuning the system to adapt to the latest changes. Compared with the traditional security solutions, what's outstanding about ZTA is that it goes far deeper into these control capabilities. Let me try to illustrate by using the case of physical access control. For example, to go to Disney World, the common practice is like you purchase a one-day ticket, you scan your ticket at the gate, and then you can play in the park and play in any games as many times as you want for that day. That is, scan the ticket only once, and then you are trusted. But with ZTA, that one ticket might not be enough to get admitted. You might need to to provide a lot of other IDs or scan your fingerprints or irises, which is called multi-factor authentication. And the security guard will check your credit history as part of a profile management. And depending on your age, your height, hobby, or the type of shoes you happen to be wearing on that morning, you are picked up and placed in one of the 1,000 queues waiting there based on fine-grained categorization. And you might not be able to play one game because the bus you took to get over here had a number that is blacklisted according to port control. And you are not allowed to enter Park B because your last venue was Park C, and Park B happens only to take traffic coming from Park A. It is called context-based access control. And you need to produce a paper consent signed by your mom to get on the roller coaster, just like a CA-issued security certificate. Once you get off the roller coaster, you might not be able to play it again because your security token has expired. And in the past months, you visited Disney World mostly on Saturdays. Therefore, your visit on Sunday will trigger an anomaly alert in user behavior analysis. All in all, with ZTA, access control scale is reduced down to the micro level, and verification happens all the time. For implementation of the functions we discussed in the last slide, on the right are the blocks that are some of the cutting-edge technologies. Let's see how they can map to each other. Identity management can rely on the latest development in human authentication, such as biometrics, device authentication, and more broadly, entity authentication, where entity can be an application or service or whichever party the access request comes from. A good use case of a blockchain in ZTA is to protect the resources. For example, to update a record in a database, when Hyperledger blockchain is applied, it takes several parties to endorse and validate independently before the transaction can be fully committed. This is a much stronger protection of integrity than just to validate the update request that takes only one single SQL call to execute. Trust evaluation is the core of the entire ZTA. Since trust is computational, a lot of algorithms can be used here, from the direct sums up of linear trust scores to more complicated math of like fuzzy theory, entropy theory, gaming theory, you name it. I placed algorithms and machine learning artificial intelligence in parallel here. That is not 100% correct because we all know that algorithms are the building blocks of a machine learning, and machine learning is a subset of artificial intelligence. But I placed them separately just to highlight that machine learning is used to discover the pattern out of the large volumes of data collected and keep refining it constantly to be used as a reference for profile management and categorization, while artificial intelligence makes the decision to allow or to block. Continuous diagnosis and mitigation is also much dependent on machine learning and AI. processing the input, building up intelligence, and provide output that drives the access control. All these requires a lot of computation power. The running of the algorithms, the repetition to get the consensus in blockchain, and the communication overheads in authentication traffic. So cost control and performance improvement plays an important role in ZTA implementation. Before closing, let's place ZTA and CASB together. Actually, they are not comparable like apple to orange because fundamentally they are addressing two different situations. CASB came out to answer the need when moving from on-prem to cloud, and where organizations need to know what's going on in the cloud usage and how to protect their business that are running on the servers they have no idea where about. Access control is just one of the vectors in CASB. ZTA, on the other hand, addresses the situation that conventional parameter control is not secure enough, and we got to break it down horizontally to micro parameters and vertically by bringing in upper layer information into the evaluation, from connection-based just to scan the IP and port in firewall to context-based dynamically control, not only verify the requesting identity, but also the entire security posture. Just like apple and orange, they are different, but in the end, they are both fruits. ZT and CASB do have something in common. For example, since cloud computing, especially public cloud, has no perimeter design to start with, zero trust access control can be well applied to CASB. And ZTA and CASB have similar deployment modes like agent deployment or proxy modes, especially reverse proxy, that is more leaning towards resource protection. And last but not least, both ZTA and CASB are terms forged during the transitional period. One is to transition from on-prem to cloud, and the other from traditional perimeter network to more sophisticated environment. Not long from now, when using cloud services in business is like driving a car in commuting, and zero trust is regarded as the intrinsic nature of IT ecosystem, the term of ZTA and CASB will be phased out eventually. Okay, that has been my takeaway from research on ZTA up to now. Hope you find it interesting. Thank you for watching.